Hello everyone, welcome back to my channel. Today we are going to solve another interesting problem, the matrix. Prior to solving problem from the matrix, we have already covered around 10 problems from the linked list, 10 problems from the array. For the each and every problem, you can find the link over here. I will highly recommend you, please try to solve problem one by one. What is the difference which I want to bring on the table is that firstly, I am trying to analyze the problem. I'm giving you the brute force approach. What is this time complexity? It's space complexity for brute force approach. How we can optimize the same problem using the optimization matrix. Once we get the optimization way, I'm writing the code for that, and then I'm finding the time and space complexity. So in this green 169 problem tracker, you can see I have listed down all different types of problem, like mainly from the two pointer, sliding window, strings, tree, if backtracking, graphs, tree, greedy algorithm, graph, 1D, 1D, 2D graph, dynamic programming. All different types of problems I have tried to cover over here. I'm highly recommending you, if you find anything useful over here, please try to hit like button and do consider subscribing as and when you find something interesting in this series. Now, without further ado, let's get jumping for solving spiral matrix. Now, given a matrix of m by n matrix, written all the elements of the matrix spiral order. So what is the expectation? Like for example, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we are not just doing by row and column. We have wanted it to go from the from the first row, then it should go the last column, then again it goes to the last column to the first row, and so on and so forth. So if we see the output 1, 2, 3, 6, 9, 8, 7, 4, 5, like 1, 2, 3, 6, 7, and then it will move like this. If we see the other example like 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7, and once it's the last element, then we are stopping the matrix. So this is the expectation from our problem. Now let's try to think how we can solve type of problem. Just a minute. So let's move our problem to solving the spiral matrix. So this is my spiral matrix. So for example, this is the 1, 2, 3, 4, and then sorry, this is 1, 2, 3, 4, then 8, 12, then 12, 11, 10, 9, 5, 6, 7. So this is what I wanted, to be printed out. For example, if I will take the simple example, yeah, just example is 5, 6, 7. So in this case, I'm having only single column, right? So it will start with the first row. It will try to find anything near left or right now. So it will try to go here and it will try to print here. So it will try to start here, print here, print here, print here, right? It is not having any difference. So it will just try to, the output of this would be only 5, 6, and 7, because that's what we are having. We didn't have any different, the column or row. We just have a single column and 3 rows. So there are different number of edge cases we'll be solving, but how we can solve that, right? Because we know that we can start from anywhere here and then we can go around. Like we can start from here. We know that it's a 0 by 0 matrix, right? It's 0, 1, 0, 2, 0, 3. But how we can go here and then again move from left to right, then again move from bottom to top, then again move from left to right. So you can see a pattern, right? We can see a pattern, right? What we are doing, firstly we are moving from left to right, okay, then we are moving from top to bottom, then we are moving from right to left, then again we are moving from bottom to top, and then again we are moving from left to right. So this is a pattern, right? So for example, you can say like our spiral matrix is basically like this. We go left to right, then top to bottom, then left to sorry, right to left, then again we go bottom to top, then again we go left to right, then again we go top to bottom, again we go left to right, right to left, then again we go bottom to top, again we go from left to right, again we go from bottom to top to bottom, again we go from left to right, right to left, again we go from bottom to top, again we go from right to left. So this continuous pattern is called spiral pattern. So for example, if I'm starting like this, I'm starting like this, I'm starting like this, I'm starting like this. So this is what I'm expecting. So as I'm said that I am going from left to right, then bottom top to bottom, then from right to left, then from bottom to top. And doing that, we are just making sure we are not considering the last element. Okay, so there are a few things which are required, like for example, like I can draw 1, 2, 3, 4. I'm just rewriting the same problem. Okay, this is my matrix. what I'm doing over here, I know that there are rows and there are columns. Okay, so this is basically 1 2 3 rows, and 1 2 3 4 there are 4 columns. What I'm doing, all the columns, right, all the columns I am declaring it as a left, and right side of that is declaring I as a column. Right here, for the rows, what I'm declaring, this is my row, so I'm just declaring top, and for the last column, for the last row, I'm just declaring it at the bottom. Okay, so as simple as it, right? So for example, if I'm just declaring left, right, top, bottom, so let me get the rows. For example, over here row is 3 and column is 4. So my left should be, right, my initially should be 0, so bottom and left should be 0. My right should be, what could be the right? Right would be the columns minus 1, because during the array we used to consider the 0, so we can remove the last index. So my right would be 3 and my row is 3, so my bottom would be 2. So if I wanted to find this element, right, so what is the matrix index array for this? This is first row, right? So matrix of first, and this is 2. So by using this, we can get the 7th element. So in a similar fashion, what I need to do, I need to traverse that. Up to when I need to traverse? Still this element is less than this, still this element is less than this, till the time I wanted to iterate, till the time I just wanted to create a spiral binding like this. Okay, up to when? Up to the point that I can't find the element which I visited earlier, right? So in this case, you can say I'm starting from here and I'm ending it over, because I didn't have a different element other than this, right? So I'm starting from left, then I'm going from top to bottom, then I'm going from right to left, then again I'm going from bottom to top, then again I'm going for left to right. So you can see the pattern, right? The things which I have visited already here, I'm visiting again, right? If I am having some element, then again I'm following the same. If I'm in element here, then I'm visiting the same stuff. If I'm having element, then I'm just visiting the same. Like this is what we need to follow, right? We will be going like this, like this, like this, like this. This is what we have to we have to come up with output. Until when? So until my last element is not, or my both left and right is not crossing, or top and bottom is not crossing. So I can write simple condition, right? Up till when I wanted to cross, my top is less than my bottom, and my left my left is less than my right. So if anything among this is fine, identified, it means that I have already covered all the element, right? So now this is the condition where I can make sure that I am moving all the element. Now what next? What next? That I am starting from this one. What is the fix in this? So this is a fix, right? My row is fixed, but my column is continuously going to change. Once I'm visiting over here, right? This is the top column. So once this is completed, because we are starting from the top, I should increment this column to show so that it go here. Once I'm completing here, I'm completing the right column. So I should move my right to here. Once I'm completing this, right? So I should move my bottom to here, right? And this top and bottom should be on the same place. So I should add a condition because I don't want it to get overlap it, and then I can again move from this to last. So this is a simple trick, like I don't want to do multiple things, and we'll just try to solve this, right? There are not that many difficult stuff over here, so let me try to solve this right now. Okay, so whatever we have done, like we definitely need to have this matrix, the size of matrix, just a minute, and this, a minute, the size of my column. Okay, then as I have written the condition, I need to find the number rows left, right. So top would be my 0, and bottom would be my, what is bottom? Bottom is my column size. What is column? Column is n minus 1. What is my left? Left is my row is right is m minus 1, because that's where I wanted to make sure that my first top is pointing to the first column, sorry, top is pointing to my first row, and bottom is pointing to last column, sorry, last row. Left is pointing to first column, right is pointing to the last column. So unless until they both, anything among them is not crossing, right? And left is not crossing the right. Okay. So unless this is not crossing, I won't wanted to move ahead. We wanted to return something, so I need to store something in my vector. So I'm just declaring a vector to use that and just return. Okay. Now what I'm doing, I just wanted to take the first column, sorry, first row, all the columns, first row, all the columns. So what is fixed right now? My first row is fixed. So what I will do, I will be starting from I is equal to left. Then I will be moving my I until I find the right. And then I'm just moving my I to this. What I'm doing over here, what is where I'm storing? I'm just storing over here. So I will just store that inside my matrix. And then what is fixed right now? My top is fixed. So I'm fixing top, and what is moving? My I is moving. So I will just add that. Once this is done, right? My first row is completed. So I should move my row to next. I should move my next to row to next. Now let me give some name so that this is left to right, right? This is left to right. Now we have already completed left to right. Now what is next? That from top to bottom I should go, right? From top to bottom I should go. So from top to bottom. We already started. We already moved from our top to next, right? What is the top right now? The top is something that we have already visited, right? Our top is something we have already visited. Now what is the next that we need to do? We just need to make sure that we are taking the next one. We are taking the next one. So in the next iteration, what I'm going to do, I'm gonna do that I will be starting my loop. Where I'm starting my loop, I'm starting my loop from the top because we're already at the top. So and until when I need to move until I reaches my bottom. You can easily able to figure it out, right? Those are the things which I am right mentioning, your left to right, then top to bottom. So I'm just making sure the I'm initializing the top and I will move my element to last. And then I'm just increasing this. What I'm doing here, so I will do the same stuff. What is fixed right now over here? What is fixed? My column is fixed because I'm moving from last column to the bottom. So my column is fixed. What is my column? Column is my right side, right? What is changing? My I is changing because I'm moving from first row to first column, then second column until I've hit the last column, right? Simple. Once this is done, right? Once this is done, after this iteration, I just need to make sure that I am moving from last column to second last column or last column minus one. Now, once this is done, what I need to do, because we have already completed our first iteration, right? We have completed our first iteration. Let me show you. Okay, so here we can see that we have already started from the top. We have already started from the top, right? We went here, then we check that whether we're up to right or not. Yes, if it is right, then we are moving our top here. From here we are moving top here, and then we are just moving from here to here. So what is my column? Column is fixed, right? So I'm just moving down. Once this is done, right? Once this is done, my right was here, so I just making sure that my right changing to this. So right now right is here, and I just need to move from my right to left. Initially what we did, we move from left to right. Now it's turned to move from left to right. Okay. For it's simple, right? It's simple. I is equal to where I'm starting. Let me write it over here so that you can understand quite easily. Right in the first, what we did, we move from left to right. Now it's our turn to move from right to left. So I should be marking it as a right, and we have already decreased it. So we are moving from high max column to zero column. So I is greater than is equal to left. It's not zero. Remember, it is not zero, because if it makes zero, then it will always try to go to zero column. But we just wanted to move inside the boundary. Now I again just try to move that matrix of. Okay. Now what is fixed over here, right? What is fixed? My last column is fixed because I'm not gonna change anything, right? So my bottom is fixed, and what is changing? My I is changing. Once this is done, right? We have already completed our last column. Sorry, we have already completed our last column. So what I will do, I will just try to make sure that I'm moving to the bottom minus minus so that I can move to the previous element of the bottom. Now what next? for right now we have already completed top to bottom. Now it's turn to go from bottom to top. Okay, so what I will do, I will again increase my I to the bottom, right, and I is greater than top, right. Oh yes, and then I should be mine. Then what is, I will just push my matrix of what is fixed right now. My column is fixed, but what is changing, my row is continuously getting changed because I'm going from top to bottom. I'm just moving from row wise, not column wise. So my column is fixed. What is my column? My column is anyway, right, because I'm just moving in the left, so my column is fixed and it's a left. But what is changing, my row is continuously getting changed. Once this is done, right, we are already completing the left column. So it's our utmost it is that once we complete the left, we should make move increments left to plus one. Once this is done, then this is, I can straight away return answer. Let me see, if we can improve anything. There would be edge cases, but we'll try to just see whether we are getting the output or not. Okay, so forget about this test cases. This test case is different, but the case first, like 1 2 3 4 5 6, you can see we are getting output. Where we are getting stuck, right, we can see that our output is not printing. Our output is printing extra 6, but we didn't expect extra 6 to be printed. Why? Now let's jump in over here and try to understand what it is. So for example, you can assume that I already written a code. I just need to make sure that whenever I'm traveling, where I should make sure that I'm not counting the last one. So I will just write the code over here. So for example, for just a minute, for is equal to left to, okay, and here what we are doing, sorry, here what we are doing, here we are just increasing our top. We are just adding. Here what I'm doing, I'm just moving from top to bottom. And what I'm doing over here, once I'm doing over here, so I'm just moving my right to minus minus. The next, what I'm doing, for what I'm doing, right to left, right to left. And here what I'm doing, I'm just considering the last column, so I will just decrease the last column. And the last, what I'm doing, I'm just moving from, we have already moved from left to right, so here in the, here we have moved from bottom to top to bottom, so I will move from bottom to top. And when this is done, I'm not increasing, I'm increasing left. So you can see that we are moving sometimes left, sometimes going back, sometimes bottom, sometimes left. But can you check that if we are starting, for example, our matrix contain 2 by 1, right? Left is, for example, we can assume 0, and right is something consider where we are moving on. So my top will go, for example, let me declare all, right? Let me declare all. For example, our matrix is, right, yeah, let's copy the same example which we were thinking initially. So let me copy the same, let me paste it over here. Okay, so what I will declare, my top would be 0, my bottom would be, top is here and bottom is here, bottom is n minus 1, so bottom is 2, left is 0, right is 4 minus 1 is, right is 3. Okay, so what I'm doing, I'm in the first row, my top is here, so I will just try to move here, right? In the first iteration, once the first loop completed, my top would be 1, my left would be 0, because my bottom would be 2, and my right would be 3, because I'm not going to change in the first loop, right? This is the first loop. This first loop, in this first loop, I will just increasing my top, so my top would be going over here. In second iteration, like in second loop, my top would be there, my left is what I'm increasing or decreasing, my left is also 0, I'm not increasing it here, but I am decreasing my right, I am decreasing my right, and my right would be bottom, I'm not increasing bottom. In the third loop, right, in the third loop, what we are doing, in the first loop, what we are doing, we are just moving from left to right, This is crucial, right? We are moving from left to right. In the second, what we are doing, we are moving from top to bottom, right? Firstly, we are moving from left to right. Secondly, we are moving from top to bottom. Here we are moving from right to left. When we are moving from the left, what we are covering? We are covering the last column. So my top would be 1, but my bottom would be changing, right? My left is again 0 and my right is again 1. Sorry, right is my 2. So my right is 2. Now what is the last? So we have moved top to bottom. We need to move from bottom to top. Okay. Until now we didn't find any extra thing, right? We are just moving smoothly, right? So what I'm doing, right? In this case, I'm just increasing my left to 1. So my top would be same. My left would be changing to 1. My left would be 1. Bottom is also 1 and right is 2. Okay. So in this case, we can see that we already cover up to until this. We already cover this and this, right? Now it's turn to go back to here. It's turn to go back here. So are we starting here? No, we are starting already from here, and we have already moved our left, right? We have already moved our left, but are we considering that whether we have moved this left or not, right? So what I'm doing, I'm starting from here, right? I'm starting from here, and if we see our output, right, we're already covering it pretty smoothly, right? We're already covering it smoothly. So 6, right? So in this case, what we are printing, like, yeah, in this case, what we are printing, let me print that. So in this case, I will try to print 1 2 3 4. In this case, I will move along and I will try to print 8 and 12. In this case, in third case, what I will do, I'm trying to print 11, 10 and 9. In this case, what I'm trying to print 9 and 5. So we have already covered, so we will just print the 5. So until now we are pretty good, right? Until now we are pretty good. When we move along, right, when we move along, right, it's a left and right. So we'll try to print 6 and 7. And then in this case, this is our left, sorry, this is our uh, top to bottom. Once we move the last iteration, then this is where we are. Okay. So here, what it will be? Okay. So here it is. Now what it will be, it is going from left to right, right? It is going from left to right. So what it will be doing, it is going from left to right. So once left and right is completed, right, once left and right complete, what we are increasing, we are increasing our top, right? We are increasing our top. So top would become 2. Let me just change the, yeah, top would become 2. Top would become 2 and my bottom is 1. Okay. Top is 2 and bottom is 1. So in this case, you can say that, if exceeding, and what was our condition, like what is our base condition that we have written? Base condition is top should be less than is equal to bottom, right? Top should be less than is equal to condition. But in the second loop, you can see that, if we are exceeding, right, if we are exceeding, then in this case, my top is increasing 2. And when we are referring our top, we are not referring our top here, we are referring our top here. So whenever we are going to check our top, so top is 2 and bottom is already 1. So in this case, we were not able to take that. So before actually doing this calculation, we need to make sure that we are checking, we are extremely checking whether top is less than the bottom or not, right? It is not going beyond the limit. So that's why here we need to make sure that whether, when we are calculating top to bottom, we should check the condition. And same goes with the right to left as well. For example, we just have a single matrix, like this is our matrix, 6 7 8, right? So in this case, our left, top, bottom and right. Okay. So my top is 0, my bottom is 2, my left is 0 and my right is 0, because we just have a single column and we just have 2 rows. So it will start here in the first iteration. Top won't be here. So what we are increasing, top would be 1, right? It will go here, right? It will try to go down. So it will try to increase what we are increasing, right? We just have a single element, right? Single element. So top will increase. In second condition, are we having anything, right? But we have to go down, right? we have to go down. So I will increase the right. So my right will go to -1, right? My bottom is 2. So once this is done, I need to make sure that I need to move, I need to check back. But are we checking that? No, right? Because our right is going back. Our right is going back. It means that we have to make sure that while checking this condition, right? Sorry, where yeah. So while checking this condition, yeah. So while checking left to right and top to bottom, we need to make sure that my left is in between the left, left should be less than right, and my top should be less than bottom. So I will just do those changes in a minute. Okay. So what I will do before actually doing this check, right? Before actually doing this left to right, what I will do, I will just include a single condition that if you are checking with the right, right? If you are checking with the right, what you are going to make sure that what is the bottom, right? What is the bottom? What is the right? So you should make sure that you are not checking beyond that. Top should be less than. If this is the condition is matching, then only in that case you are supposed to decrease the bottom, right? You are supposed to decrease the bottom, and same goes to the bottom to top. What we are referring? We are referring left. So if my left is less than right, right? Only in this case you are allowed to decrease the or increase the right. I think with this I have added everything. Let me just try to give the getting the answer. Okay. Oh shit. And okay. So I think we have covered all the edge cases because I have already explained why we are comparing top left, and just let me try to submit it. Yeah. So I think we are able to solve this. Now let's try to get the time and space complexity, time complexity and space complexity. So what we are doing over here, like we are declaring 4 different variable, top, left, bottom, and we are moving along all the matrix. Like we are moving all the matrix. So in simple way, right? In simple way, that the time complexity would be, right? We are moving, we are visiting each node exactly once, right? Each node exactly once, and we have, for example, there are 12 elements. 3 by 4, it's 12 elements. So there are, for example, n into m. So that's how my time complexity would be, the number of rows into number of columns. What is my space complexity, right? So we are declaring 4 different variables like left, right, bottom column. But are we using any extra space to process? We are using this vector integer, but we are expecting output to be stored in this. So we are not using any extra space. So space complexity would be simply of 1. With this, I think we'll conclude the video, and we'll try to see for the next videos. With this, thank you so much. Bye-bye.